Hello viewers, welcome back to the Multimagics channel. So this particular video is the 7th video in the series of audio segment, and today we'll be discussing about a project called Audio File Stream, where we'll be streaming an audio file from a server, and at the client side you can listen to that stream with the help of a player. So let's jump into the details of today's video, and I am pretty much excited today to share much more details about this project. So first thing first, let's discuss about the prerequisites, like what installations are needed, and let me go through introduction about few transport protocols in the multimedia segment, and also I will go through the architecture of the audio file stream service, and I will also go through the code flow and the GitHub links and the upcoming projects. So this is the agenda for us today. So let's start into the prerequisite section quickly. So of course, for this entire audio series, we are following Windows platform and the architecture is x86, and the IDE we are using is Visual Studio 2010 and above. I am currently using MSVC 2022, and the third party libraries I am using for this particular project is LIVE555, and LIVE555 libs are already generated from the source and placed on the libs the GitHub link. So I will go through each and every details about what is LIVE555 and other details too in the upcoming slides. See, let's start with this simple thing. So what are multimedia applications classified as? You know, generally from YouTube point of view and Spotify point of view, we are just streaming a stored audio and video files. So that is what basically it is about YouTube and Spotify and other multimedia applications. And the other category is about the conversational applications like Skype and Teams, where we, as a team, as a group, we can have conversation. And the other type of the media application is about streaming live. So in general, we'll be streaming the live events, the live events like that. So these, with the help of this project, whatever we are about to discuss, you can build your own application like YouTube Music or Spotify or even YouTube also, video segment point of view. So this will be a very interesting video, and I will be going through a lot of basics, and I will try to make them as simple as possible. And if you have any questions or queries in this video, you can post it in the comment section. So let's start this video. What is the streaming audio project? So very simple. See, let's say we have a client, or let's say we have a server called digital media server, and in this at a server we have a set of audio files. For example, one such file is called audio.amr, and in the client we have a streaming application. So the streaming VLC supports streaming application, streaming of the audio also. So let's say in the client machine we have one such application, and over the network we can listen to the audio. Instead of physically downloading this file to the client machine and then playing back, over the network we will be listening to the audio. In other words, I can say over the stream, we will be streaming the audio over the network, and then the client should be able to listen to that stream. Okay, so this is about today's project, and this is at high level what we'll be discussing today. So our focus is to develop an audio streaming application, like this audio streaming application or a local digital media server which supports streaming of audio using LIVE555. Okay, so this is about what we'll be discussing in today's video about streaming an audio file. So before discussing streaming an audio file, let's see the streaming architecture. So we have a multimedia applications over the network. So what is the typical architecture? See, let's say we have a server here. So I hope everyone knows about clients or architecture, all those things, and I'm not going to the inner details of it. So for now, if you have a streaming server, and in the server you have a storage, and that particular storage you have audio files and video files, all these things. So if any client requests to listen to this particular audio or video stream, what happens is this audio file, whatever the content inside this audio file, will go to the application layer, and the application layer will pass the data and the other details to the transport protocols. So these transport protocols, the transport protocols here in the sense is nothing but the In the TCP IP stack, we have a transport layer. In that we'll be having a set of transport protocols. So the data is now sent to the transport protocols, and the transport protocol sends the data over the net, and then at the client side we'll be receiving this data by the transport layer, and from there it goes to the application layer, and then from application layer the data goes to the streaming application. Here the streaming application decodes video and audio in sync, and then provides and then displays that onto the screen. So if it is audio only, the audio information will be there, and if it is video information. For audio and video, everything will be displayed on the screen. So this is how a streaming application, a multimedia streaming application works over a network. So you have a server, you have a client. From server you are sending data to the client. Client receives the data and then displays it onto the application, streaming application. And the protocols which were used to achieve these are transport protocols. I will be going through which protocols are used for the multimedia point of view, and this is the application layer stack. So I hope I am clear until now. So let's quickly move on to the next slide. So this is about the protocol stack for multimedia applications. So in the last slide we have seen, okay, the data, audio and video data this is sending to the client with the help of transport protocols, and the protocols we will be using is three types of protocols. I mean, there are a lot of other advanced protocols nowadays also, but in this particular video I am just sticking to these particular set of protocols. So will be using RTP layer, and then we will be using RTCP protocol, and we will be using RTSP protocol. So why we are sticking only to this particular set of protocols as of now is, as you know, we are also new to this particular streaming applications. We started exploring it step by step. So in the first layer I am just explaining about how the existing well-known protocols are used. There are also a lot of advanced protocols. I am starting with here. This video scope is only confined usage of this particular protocols. So here it is the RTP protocol we are using, RTCP we are using, RTSP we are using, and then so for example, this is the server, and on the server we have the files, and then this is the client machine, and the this is the on the server side. This is how the stack look like. So first the data is being taken care by the RTP layer, where the actual audio and video data, actual real data is being taken care by this RTP protocol while sending to the client, and this internally uses UDP actually. And RTCP is also a protocol. This is for session control, like when to in other words, it will collect some statistics of this particular stream, like whether the bandwidth is good or whether a kind of network is good or not. So like all other monitoring kind of stuff, this protocol takes care. And RTSP is a kind of a control protocol where you can pause the stream, where you can stop the stream, where you can play the stream. So it is like a control. So in other words, these two RTCP and RTSP protocols are more of a control protocols, and the actual data transfer from client to server is happening with the help of RTP protocol with the help of UDP, and RTSP internally uses TCP layer. So all this information now is passed to the IP layer, and from IP it passed to the network, and from here it reaches to the client. So this is how data transfers from client to server from stack point of view. This is architecture point of view, and this is from the protocol stack point of view, how the data transfers from one layer to the other and finally reaches to the internet layer, and from there to the client. So before going much into this particular project, let's quickly recap, or let's quickly memorize the actual meaning of these protocols, whatever we have discussed in the last slide. So RTP, as I said, it is a real-time transport protocol. It is primarily responsible for the transmission of the real-time data, such as audio and video over a network. It provides mechanism for the delivery of the data with low latency and jitter. And the futures of this RTP protocol is RTP protocol will send the data or will transfer in the form of packets. We'll be having n number of packets over the stream. Okay, so over the stream or over the network, these packets will keep on transferring to the client until the all the data inside the file is read. Okay, so in each packet we'll be having sequence number to the packets, we'll be having timestamps associated with, and we'll be having type of data being carried, whether it is audio packet or video packet. So a lot of all these details is combined inside the RTP protocol. I mean, RTP takes care of all these things while transferring the data. So now what is RTCP? So while RTP is transferring, RTCP works in conjunction with RTP. It means like there is no specific protocol called RTCP. I mean, in the other ways, you can't transfer the data only with the help of RTCP. So RTCP works in conjunction with RTP or in collaboration with RTP, and RTCP is called real-time transport control protocol. So the name suggests itself it is a control protocol. So what it controls? It controls the feedback on the quality of the data transmission. It checks what is the bandwidth at the client and the server, how many amount of data is transferred, is there any loss in the data. So all those such details, it is taken care by the RTCP protocol. So based upon this RTCP, based upon the statistics and loss of data, the transfer adjusts accordingly. So it sends information to RTP, okay, now this losses data, ensure it tries to resend. So all those control things will be taken care by the RTCP. So it is responsible for completing functions such as synchronization, quality of service management, and it contains RTCP packets contain information such as number of data packets and number of lost data packets. So RTP contains timestamps, all things, whereas RTCP contains the number of packets sent and lost. Okay, using this information, it dynamically changes the transmission rate and even change the payload time. So that is how the data is being, the transmission of the data is being controlled by the RTCP with the help of the statistics it contains in the each packet. Okay, so this is about a high level overview of RTCP. As I mentioned, we are also kind of learning things. Maybe we are trying to put as much as best we can in this particular video, but I feel this is a good enough thing to know about RTP and RTCP. To know more depth about these protocols, you can refer to the other things, but this is from this video point of view, this is good enough to understand about the RTCP. So now let's move on to the next protocol, which is RTSP. So RTSP is also in conjunction works with RTP, and it is a network protocol designed for controlling the streaming media servers. So RTSP is used to initiate and control the delivery of streaming media content. So it in generally RTSP protocol also works in conjunction with RTP, and apart from RTCP, RTSP is also responsible for controlling. In RTCP takes care of controlling the transmission rate, whereas the RTSP is responsible for controlling the stream. Like you can pass the stream, you can play the stream, you can stop the stream. So lot of kind of events. This is kind of more of a high level actions. Okay, so this is how RTSP protocol works in conjunction with RTP and RTCP. Okay, so now let's see at overall, if you want to transmit any stream or any audio or video data over the network to the clients, so three protocols comes into the picture. So RTSP, RTP and RTCP. So as I mentioned, RTCP and RTSP works in conjunction with RTP. So RTP transfer the actual audio video data, whereas RTSP will have all the metadata information like and all the other details, and RTCP will have the other details like when quality details, where packets information, number of packets, all other things will be having in this RTCP. All statistics will be having in this RTCP packets. Okay, so with the help of all these three protocols together, in real time we will be passing an information from the RTSP. We'll be passing information from RTSP server, also called as a digital media server machine, to the streaming applications or to the streaming clients which supports the RTSP. So VLC player is one such application which supports streaming and which also supports the RTSP streaming in specific. Okay, so to make it simple, RTSP is responsible for session initiation, control, and the establishment of streaming sessions, and the RTSP is not responsible for data transmission. It uses RTCP and RTP for monitoring and transporting the media content. So as we discussed, RTSP will just control the session, but the actual transfer of the data happens with the help of RTP only. Okay, when RTSP process stream starts, it will cut the large data into small packets on the available bandwidth between endpoints, so that client can play one packet while it decompressing the second or even downloading a third packet at the same time. So RTSP, it determines actual stream, and it cuts the data into the packets, and these packets will be transferred with the help of RTP to the server, to the client, and the client actually decodes this and then displays to the and then it just decodes and gives the information to the rendering machine or to the display. In parallel, the other packets keeps coming to the client, to the server, to the client. Yeah, so like this, without actually physically downloading the file from the server, with the help of the stream, with the help of servers, RTSP protocols, all those things coming together, we can stream the audio data or video data across the network, and the clients can listen to that particular audio over the stream. So now let's quickly go through the RTSP methods. So since RTSP is a client server mechanism, so between client and server certain handshakes will be happening, and these are the methods that are called by the client and the server in conjunction together. So these are like options which determines the capabilities of server and client. Like describe is one such method, announce, setup, record, play, pause, redirect, tear down, set parameter, get parameter, and these are the details about this particular method. So the main thing is like setup, play, pause, tear down. So these are the four things we'll be using majorly, and these are like optional methods like options, describe, set parameter, get. These are like optional methods, depends upon the need and requirement. RTSP will be using these particular methods. Okay, so this is how an RTSP session looks in the real time. So this is the RTSP server where our physical audio files, video files will be there, and our once the RTSP server starts, whatever files are available, it is available for the streaming, and the RTSP client will get all the packets. And these are the lot of methods that involves while collecting the data from server to the client. So as we discussed, so options, describe, setup, play, and once after play starts, the actual data transfers from server to client using RTP and RTCP. And particularly finally, once all the data is transferred, the session stops or tear down happens. So that's what I have been mentioned here. So these options will get the interfaces, and then using describe we'll be getting the live streaming media information, and from setup we will getting the server that needs to establish corresponding media data transmission channel, and play means it simply start playing, and then it will actually transports the data with the help of RTCP and RTP packets, and steer down ends the stream. So far we have discussed how a streaming architecture looks like, and how to pass audio video data over the network to the client, and what are the protocols involved, RTP, RTCP, and RTSP, how these protocols three together helps to transfer the data from server to the client, and what are the kind of methods involved in to establish smooth flow of the data, and what each method plays, all these definitions we have seen. So now we have get an idea what is the streaming, what are the protocols, what are the other things. So now in real time, actually, if you want to develop a protocol and then to call all those methods with the help of RTSP libraries, it is a bit tough because a lot of things we need to control from our end. Rather than that, LIVE555 is one such framework or a library which is written in C++, which implements the entire RTSP structure here in the sense like setup, play, option, handshake, like all those methods which we have discussed in the previous slide. So all these things, it will be automatically taken care by the LIVE555. Only thing is you need to call the right set of APIs to make that happen properly. So LIVE555 supports lot of video audio formats including H.264, H.265, MPEG, AAC and other video and audio encodings. So these are the core modules in the LIVE555 framework: usage environment, basic usage environment, live media, and then the group socket. So usage environment helps to create or build the environment for the streaming applications, and then it handles all the asynchronous and event processing details, or is at high level it is handled by this particular module. And the basic usage environment is a simple implementation of it is like kind of extension to this usage environment. And the live media is actually the heart of the LIVE555, where this particular core modules actually implements the RTSP protocol stack, like and then the encapsulation of all the methods inside it and parsing of the actual format encoding data. Okay, so live media is the heart of this LIVE555 framework. This is the actual core module where actually the RTSP protocol is being implemented internally by this particular APIs inside this module, and these are the supporting environments, and this is for creating sockets and then port numbers. For controlling all those things we'll need this group socket module. Okay, so the next is we'll have quickly look at what is there in the LIVE555. So in the LIVE555 we have it is classified majorly into two things. One is source and one is sink. So source here in the sense, what is the source, whether it is audio file or video file or it is like stream byte or some H.264 source. So we have a lot of source classes. So each one is a class. So here we will be having a media source in our case, and we'll be having a lot of sinks. Each sink is a separate class: media sink, RTP sink, multi-frame. Here we will be having a media sink. In this particular example, we'll be using this class and we'll be using this media source class. Okay, I mean we'll be using a media sink. So now this is like subsessions where you start the session, close the session, end the session. These are all for the RTSP. These are more related to the session controlling classes. Okay, so we'll be using server media subsession in our example. Okay, so this is the code flow. So basically we have seen what is the streaming architecture, what are the protocols involved, and how all the protocols exchange data and how it plays a key role in exchanging the data between the client and server, and how LIVE555 makes it simple in and implementing all those details in one go, and these are all the corresponding classes. So now we will see how with the help of this information, with this knowledge, we can create a server application in C++ which streams the audio data, and the APIs we'll be using to create a server applications is from the LIVE555 framework. So first we need to create the audio source here. So this, as I mentioned, will be we will be using RTP sync here. So I think I mentioned we'll be using media sync, but we'll be using here RTP sync here, and the source we'll be using here is the audio source. I mean like it is not mentioned in this, but it is, if you download the library, this particular class will be there, AMR audio file source. So the source is AMR and the sync is RTP sync. So these are the two main classes we'll be using, and we'll be populating all the data related to this. And this is about the basic file. Test.amr is the file we'll be streaming. Okay, so now once the declarations are happening, we'll be setting up the basic environment. So I am telling to my environment, you schedule a create, you schedule it. It means like whenever a file is there and whenever the server starts, this particular scheduler will go and start will start reading that file and other things happens. The rest of the flow start triggers. So first we need to, once the scheduler is ready, so first we need to ensure to which, what is the destination address. So a random IP is chosen actually. So to which client or to which server we need to cast our stream. So I mean, in other words, it is the IP of the server. Okay. And then so this IP is needed for the client to connect to this server. And then we should enable the port numbers, because as we are talking over the network, typically we need port numbers. So this is for RTP and this is for RTCP, and RTSP uses TCP stack. Since this uses UDP, RTP and RTCP, we need the port numbers for this. This is the RTP port numbers and this is the RTCP port numbers, and this is the TTL port number. Okay, so these port numbers and other things are used by these group sockets, and then finally finally we created sockets. So whenever the streaming starts, the port gets the port listens to that on a particular port number, and whenever a request happens from the client, the data transfer starts to the client from the server with the help of these ports. And then, as I mentioned, the two main things we'll be using is RTP sync, which is the audio sync, and also we will be using this instance of the RTCP instance. So as I mentioned, we'll be using RTP sync, and we'll be using the AMR audio source sync. So we have populated all the required data for the sync, and for the RTP, for the RTP sync, yeah, we got all the data, which is nothing but the audio sync data, and we got all the source data, which is the input file. So now finally we need to create an instance of RTCP. Yeah, so this is the RTCP instance where you will be passing all the socket names, audio sync information. So all other things are passed here. Okay. After creating the instance, actually we need to create the server application. So the default port of RTSP server is 8554. So what happens is, here we'll be creating an RTSP server, and this server makes use of this RTCP instance and this RTP audio sync. So as I mentioned, RTSP uses RTP sync and then RTCP instance, and these two things are used by this RTSP server, and all the details are encapsulated in this environment. And then and it is the port number it is used. So once the server is created, you need to attach the session to that server. Okay, so to that RTSP we are attaching this particular session, means which file to stream. In this input file we are already attaching the test.amr, and then we are adding that session to this particular, that sync is attached. The sync is attached to the session, and session is attached to the server media session. Okay, so that's how the server, we are attaching a media session to the RTSP server, telling that to start the media stream, which is like audio data here in this kind. So now next is, we will be actually things are almost ready here. So here we will be getting the URL for the client to use, and then and this URL we need to use for the client to connect to the server and then play back the stream. Okay, so in the next step, actually it's almost we will be beginning the stream here, and then once inside this play function, we'll be actually playing the audio sync. So this audio sync is attached to a RTSP server, and the RTSP server internally uses RTCP subsessions and then the media sessions, and then with the help of those things we will be streaming the data. And then this streaming continuously is being done with the help of this event loop. So event loop means when once one packet is ready, event is triggered and it sends the data to the client. So like this event loop runs forever until all the packets from that particular file are read and sent to the client, and then again this event loop again kickstarts reading of the file again. So like this event loop is responsible for continuously monitoring this play. And then now if you are done, we can stop playing and then we can close the stream here. Okay, so this is how with the help of LIVE555 core modules, we have built a RTSP server which streams the audio data, and the client or the RTSP client or RTSP streaming player can read that, should request to that particular stream or hit that URL, and then you can play back the audio on the application. So whatever we have discussed so far, so let's have a quick look on the demo point of view. And the project is already inside this project called AMR file stream inside this link. So please go through this particular link. So this is my project here, which is called AMR file sync. So this is reading a test.amr file. So we will be streaming this audio file now over the network, and we will, with the help of this is my client, this is the RTSP client, and this client will read the data from this particular server application. So my locally server is running locally and the client is also running locally on the same machine, but it's on two different actually if server will be on one machine, client can be run on another machine, but for simplicity point of view, I'm running locally on same machine. So as we discussed, this is how we create environment, we create port numbers, we get the destination address URL, and then we attach the audio sync, and then we create an RTCP instance, and how do we start the RTSP server finally, and then how do we attach the audio sync to the substations, and then after playing what happens, and during playing what are the methods we call. So this is like whatever we discussed in the snippets, so simply a straightforward application. So before running this application, let's quickly play back what is there inside this file. So let's first listen on. So I am playing this audio file directly on the server with the help of a player. I am not streaming at this point. I am not running my application. So I am stopping. So the same music keeps coming, and so that is the file we are about to stream. So now let's start the stream with the help of, so okay, so I am running my application here. So it says okay, it started. So it says playing this stream. This stream is whatever audio file test with the help of, so, and this is the URL. So now this from server we are streaming the audio file, but no one is listening to this particular stream. So now what happens is, this is the client, and this client should send a request to this particular server. So if you go to media, open network stream, so the details are already given here. So now if I simply click play, now you can listen back. There you go. Okay, it started again. Yeah. So I can say I can pause the stream here, and I can explain again. So this is an RTSP server application where the server reads the file and streams the information over the network with the help of RTSP protocols and RTCP protocol and RTP protocols, and the server and the client, this is a RTSP client, which is nothing but the VLC which supports the streaming. And now if I will continue the stream. So here you can see it is continuously looping that event mechanism. It simply reads the file, and again unless and until this connection between the client and server is halted, the file keeps running in the loop, and once you stop the server, the stream gets stopped, and then the playback also stops. Okay, so this is the demo about the streaming application. So this is very simple but at a powerful, where all the current applications, all other things will be running with the help of this particular architecture. Maybe they might be using the latest protocols, but the functionality is similar. where you will stream the data. This is what is being used across YouTube, Spotify, and all other things. Okay, so I hope everyone had a good time watching this video. So as I mentioned, this is kind of a new to us also. If anything which are not clear of anything, if it is more details are needed, we can give more details. If you can mention that in the comment section. So I hope you thoroughly enjoyed this video. And then the next project, it will be an interesting project called AMR live stream. So instead of streaming the physical file which is stored on the server, we will be streaming the data, audio data, which is captured in the live. So let's say I have a client. See, I am a client. I am speaking something, and that information is encoded as a packets and sent to the server. And server actually, again, it do some packetization and sends the data over the stream. And the other client has to just simply connect to that particular, and then you can. So this is like kind of a conversation audio where I speak, and other guy will be listening to my thing, whatever I'm speaking, the other person will be listening to it, and then this entire thing is happening over the network. This is also a very interesting. This is like architecture where it will be used across the Microsoft Teams and Skype. So we'll be discussing this in the next video. So for now, please go through the details of this video. If any doubts, please do contact us via blog, or you can contact us in the comments in this particular audio series segment. Until then, have a good night. Take care.